is the sun, the sea, the sun, and Sir Raman, the voyage of the SS Narkunda, the deep blue sea, let's raise a toast to Sir Raman, my first encounter with the Raman effect, modeling the Raman effect quantum mechanically, trilinear Hamiltonian system, quantum entanglement in trilinear Hamiltonian systems, the uncle's effects confronts the nephew's discovery, our very brief review of our work, and then conclusion. So basically you heard the whole talk, so people who are feeling tired can now leave. I also learned from IPA a very interesting thing while editing Physics News, and since there are so many young people in the audience, I'll share this with you, that any time that you download or print out images, as I have in this talk, you are subject to copyright rules, and these copyright rules you can infringe upon only if you use the material for classroom teaching, lectures such as this one, presentations, and other instructional activities. Otherwise, you have to get copyright through the Elsevier Rights Department. So I thought I would start out with this. You know, for example, before movies, they say that any material which bears resemblance to real life is purely coincidental. So I have not infringed any copyright rules with this talk. There is a saying in English, may all your blues be the ocean and the sky. Now it's funny that we should distinguish your blues from the ocean and the sky, because Lord Rayleigh told us that the blue of the ocean is same as the blue of the sky. So why have so many blues? If you may as well say, may all of your blues be the sky, which is what Lord Rayleigh told us. And that's what we learn. And he also said that the much admired blueness of the ocean is due to the reflection of the sky. However, this was until Sir C.V. Raman went with his observant eye traveling on the ship SS Nartunga, a very, very famous ship. It evacuated a lot of soldiers out of Singapore during the time when the Japanese invaded. And it turned out, interestingly enough, that many years later, it's the same ship on which S. Chandrasekhar, Raman's nephew, traveled also. So now Raman went to England to a conference on academic administrators of the British Raj. But you ask, he went to England, and we have this story about how he looked at the blue of the sea, and he looked at the blue of the sky, and he noticed that the blue of the sea was not the blue of the sky, and he looked at the blue of the sea, which the scattered blue from the sea through a Nicol prism at its Brewster angle, such that the scattered light had all scattered away, and so you could only see the ocean. And if the ocean had been only due to the scattered light from the sky, then you would not have seen the blue through the Nicol prism. But nobody ever asked why did he carry a Nicol prism? He was going to a conference he was going to a conference of British administrators. Normal people don't carry Nicol prisms in their pockets, especially those which are just at the angle that are going to scatter the blue light from the sky. Well, it turned out Raman was a very unusual, to say the least, person. When he traveled, in his bag, there was always Nicol prisms, a small telescope, attachable polarizers and analyzers, a slit, and a diffraction grating. So his luggage always carried these. So it's no surprise that when he saw the blue of the sea, and then the other question I'm often asked is, why did it have to occur to him on the Mediterranean Sea? Why not in the Bay of Bengal, which he could open his window and see in Calcutta? And the reason is, again, that this Mediterranean Sea and the Red Sea, they are so deep that the depth of the sea makes the water much bluer and much different in color from the sky. So he could actually see the contrast between the sky and the sea a lot more clearer on a journey in which he had nothing to do, and he had a bunch of prisms and analyzers and diffraction gratings in his pocket. So he utilized all of them. In fact, he even used the diffraction grating to show the wavelength that was actually being scattered by the water molecules, and show that it was the maxima was at a different point from the maxima from the sky. So this whole journey, instead of carrying a novel, he got himself a Nobel Prize through it. So that is an interesting lesson, lesson to learn. Okay, so he came back and he gave a lecture to the South Indian Physics Association in Bombay. He came back and he started experimenting with tubes of alcohol. And the student, although K.S. Krishnan gets a lot of mention in Raman's work, it is really a student called K.G. Ramanathan who did all this work of looking for the spectrum of lines that come out of examining a number of concentrations of alcohol. And K.G. Ramanathan was the first person from University of Madras to actually get a DSc degree. So he is completely lost, and we have this big, sort of ego relationship between Krishnan and Raman, often often talked about, but nobody talks about the other great students of Raman. I will tell you some more great students of Raman that nobody talks about. And so what Raman effect really is, as Professor Narayan Rao has told you, is that the light, incident light, the Rayleigh scattering is that it gets reflected and does not change wavelength, whereas in Raman light, it gets absorbed by the vibrational levels of the molecules of water, and it gets emitted as different colors. Okay, one being Stokes and the other being anti-Stokes. Okay, so it is not the elastic scattering of photons with vibrational modes, but the inelastic scattering. When the material absorbs energy and the emitted photon has a lower energy than the absorbed photon, that is called Stokes-Raman scattering. And when the material loses energy, it becomes anti-Stokes scattering. I forgot to mention one thing. Nobody believed Raman effect for a long time until nobody could reproduce Raman's results in the Western world until Peter Prigsheim. He was able to reproduce the results, and he is the person who gave the Raman effect its name. It was not given by anybody here. So this is my journey. So this was my journey to University of Chicago, and we were given a compulsory PhD. If you are a theoretician, you're given a compulsory project, take a whole bunch of instruments and design an experiment to test some modern day phenomena. So I had a very enterprising lab mate. His name is Scott Schenker. He's now professor of computer science at Berkeley, and he was always trying to make me drink beer at the Friday parties which we had, and I would not drink beer, saying that good Indian girls don't drink alcohol. Right? So therefore he said, okay, good Indian girl, we'll bring the 3 or 4 bottles that they have, and we will design a Raman spectrometer, because we have the equipment here, and we'll put each beer in, and then we will see how much alcohol each beer has, and the lowest one you have to take a sip of. Okay, so I thought that, if it has hardly any alcohol, you can take a sip of it. And the thing is that I thought that they would all have a lot of alcohol. And luckily enough, I have a, you can't see it from there, but this is the graph we got of the intensity. This is the anti-Stokes and the Stokes line. And you see these blue and red ones, they are basic, these two are the above two, okay. The yellow one is 10% alcohol, okay, so nothing doing, right? The green one is 4% alcohol, still nothing doing, even though it's not, now it is okay. The magenta is 1% alcohol, and the last one, which you don't even see, is the 0.1% alcohol. And it turned out there is an American beer with 0.1% alcohol, and it's called Coors Light. You know, so that was Raman effect and beer experimentation at the same time. Okay, so if you drink Coors Light and you pretend to be drunk, everybody will know that.
Can you tell us which is the 10% one? That is more interesting.
The 10% one is a German beer. It's a Pilsner. It's what everybody loves to drink, right? So nobody touches Coors Light. It's for Indian girls. So actually, so that is how you do in your health. Somebody in our department is doing something which actually improves your health through Raman effect, and they have used surface, the SERS, that is surface enhanced Raman scattering. This is what he has told me, that he has discovered a new technology for low detection of glucose molecules, and it can be used to make non-invasive glucose monitor from things like saliva. And the thing is that what they have done is they have attached it to the surface of a silver nanocluster, and because it's so localized, the field of interaction between the light and the surface plasmons is very strong, and therefore it can enhance the glucose signal by 6 orders of magnitude. So it is very good for babies and women. So this is one another healthy use. A third healthy use of which I have not prepared slides of is Chinese herbal medicine. Chinese herbal medicine is doing quality control and testing of all its medicines. Oh.